We discussed earlier in the first two lectures, I think, when we talked about the relationship between inflation and unemployment. And in the videos that I recorded last week, that I posted last week on Learning Central, I give a background of what Phillips curve is, and we explain how that data from 1960s show that, or 1958 show that there is something which looks like a negative relationship between inflation and the unemployment rate, which was found in other data as well. So the original paper was to do with the in the UK, and then the same thing seems to appear in data from the US as well. So at that point in 1960s, as we said, the Phillips curve became a very important part of macroeconomic thinking and policy during 1960s, because this was found in the data, and the idea here is that if you want to, there's a trade-off between inflation and employment. So if you want to reduce inflation, then you have to tolerate a higher unemployment rate, and vice versa. So if you want to lower the unemployment rate, then that has a cost of higher inflation rate. So this is something, the link that shifting the aggregate demand to the right, that means we would need, or there's more demand for labor. That means unemployment rate will fall. And when unemployment rate fall, we discussed this when we talked about labor market, then that means will push wages up, and that will push prices up. Of course, we discussed this in the labor market when we discussed the different determinants of the unemployment. So the idea here is that for some time the policy option was basically which choice. So if you want to reduce inflation, then you have to tolerate unemployment, etc. And if you want to reduce unemployment, then that will come at a cost of inflation. So basically, you need to decide what type or what rate of inflation you will target, and based on that, you decide where to be between these two, inflation and unemployment rate. So this relationship, had some modification afterwards, because what happened in 1970s, because of the oil price shocks of the 1970s. So, and then we moved to something like augmenting the original Phillips curve by including expectations about inflation and also supply shocks. So what we see here is the destination. This is what the Phillips curve look like, okay? And this is the augmented one. So this is not the original, this is the augmented one, where inflation, pi here depends on expected inflation or expectations about inflation or expected inflation. And this component here, or this term here, is basically cyclical unemployment. So it's the distance between, or the deviation of unemployment rate from its natural rate, and plus some component here or some term here which represent supply shocks. So so this is the, as I said, this is the destination, or this is what Phillips curve suggests, and it basically tells us that in this context, okay, the relationship is still negative. Okay, so we have still between inflation and the unemployment or cyclical unemployment here. See, this is still negative. But also it includes expectations of inflation, so expected inflation, and it also consider supply shocks. Okay, so this is something we discussed in the video, and also we discussed in the video how you can drive the Phillips curve from the short run aggregate supply curve, and this is the first question in our tutorial sheet today. So the question asks you, I'll share the tutorial sheet in a moment, but just to let you know, the tutorial sheet already on Learning Central. But anyway, so the first question asks you to explain the relationship between Phillips curve and the aggregate supply. So this is what you see here. This is the short-run aggregate supply curve, the first equation, which basically tell us the output level will depend on its full employment level, or Y bar, and the deviation, or the unexpected inflation, which basically the difference between the actual price and the expected price level. So if the actual price, if P turns to be equal, or if the expectation, or what people expected about prices, then this term will equal 0, so this will cancel out. So basically the output level will be at its natural rate, or at its full employment output level. In the videos, I discuss how to drive the Phillips curve from this short-run aggregate supply curve. Was basically very straightforward, because you just solve for P here, and you add the supply shock, or the terms to do with supply shocks, and then with little bit of manipulation, you can actually here just subtract from BT minus 1, because we care about inflation, not the price level itself. And that will give us something very similar to the equation we saw in the previous slide. And the only difference here is just basically 1 over alpha. This is basically the beta coefficient, the beta 1, or the coefficient beta that we saw in the previous slide. And this is the output gap, which basically, again, could be represented by this here, here, which is could be represented by this distance here, which is the how much unemployment deviate from its natural rate, which basically cyclical unemployment. Okay, so our output gap, is the same. So and then we show how we can actually from there we obtain the Phillips curve that we saw. So this is something we discuss in detail in the videos. So that's why I am going through this very quickly. But of course, if you have any questions, let me know, or if you want me to slow down, I'm happy to slow down. But as I said, this is just a recap of what we already covered in the videos last week. And hopefully we'll have time to review this material. And then we move to the tutorial later in a few minutes. So in this, as I said, the first question in the tutorial sheet ask you to compare or to explain how Phillips curve is related to the aggregate supply. And basically, as you can see, both curves, or both equations give us very similar information, if not exactly the same information, but they give this information different ways. So basically here in the short-run aggregate supply curve, output level is related to unexpected, inflation, or unexpected price changes. If you move this to the other side, so basically it will give you something very similar to this one. So basically, if we say pi minus pi e equal this term here, so basically it tells us exactly it's the same thing. So basically, economic activities, or real economic activities, the relationship between real economic activity and unexpected inflation. So output related in the first equation, output related to unexpected movement in the price level. You see, that's the price level. While in this one, it will be expected to, again, to unexpected, because if we move the pi e the other side, I think I did this in a different slide. Yeah, here. So if you do that, that's what I was talking about. So if you do that here, so basically, again, so the economic activity here, again, depends on this sort of unexpected level of inflation. So basically, both equations just telling us the same thing, and that is that is how both are related, and that explain why many economists deal with Phillips curve and the supply curve as the same thing. Okay, because though both give us the same information. As I said here, this left-hand side is basically unexpected inflation. And of course, the difference here between these two, these are the cyclical unemployment, or the deviation of the unemployment rate from its natural rate. And new here, or this term here, we know already that this is the supply shock or supply shocks. Okay, so this is something we discussed already in the videos, and hopefully, but this is one of the questions that we need to cover in the tutorial sheet. So as I said, in 1970s, this a straightforward relationship was kind of broke down, but then considering expectations about inflation, and augmenting Phillips curve. With considering after considering expectations, that's why it's called expectation. The equation we saw is actually called not the original. It is not the original Phillips curve. It's actually called the expectations augmented Phillips curve. So anyway, so we already covered this, and as I said, it's just considering expectations, and one way to think about how people expect, or how economic agents form their expectations of prices or inflation. So basically, one mechanism is adaptive expectations, which basically tell us that expected inflation So we just show us the, as I said, this is the same equation, but the only difference here is just you replace this expectation about inflation by inflation in time t-1. Okay, so this is one mechanism of how agents may form expectation about inflation, and this is something. We also discussed the cost push inflation, or two causes of rising or changes in inflation: cost push inflation and the demand pull inflation. Okay, so this is the second question. Our tutorial sheet is basically to explain both demand pull inflation and cost push inflation, and in the lecture or in the videos, we explain how when expectation change, that higher inflation, that Phillips curve will shift to the right, so or shift upward, like to the red color here. So that's because of changes to expectation of prices. So we also briefly mentioned the sacrifice ratio, and again, this is another question in the tutorial sheet. Okay, okay, I just noticed that question now. So somebody said that the tutorial sheet might not be available on Learning Central, say it's been deleted. So I will check the tutorial sheet when we finish, but I will share the tutorial sheet with you now when we go through the tutorial sheet now. So this is something we will cover today. So don't worry if in Learning Central says that the sheet was deleted. It might have happened by mistake, but yeah, so I will upload it again. So this is not a problem, but thank you for letting me know. That's good to know. So I will upload it again. So one thing I covered also in the videos is something called the sacrifice ratio. So we know if we want now to reduce inflation, then you need to restrain or reduce aggregate demand, and that will cause unemployment to rise above its natural rate. So the sacrifice ratio will measure the percentage of a year's GDP that must be forgone to reduce inflation by 1 percentage point. So if let's say if we want to reduce, let's say inflation by 1%, okay, and that means I have to reduce output by, let's say, 2% or 3%, or some papers estimate this at 5%, for example. So this is kind of estimation. So if, for example, inflation was at 6%, and I want to reduce it to 2%, so that means I want to reduce inflation by 4%. If the sacrifice ratio is 5%, so that means I would lose in GDP is the loss or the sacrifice ratio. I'm going to use the sacrifice ratio to calculate the loss in GDP. So the loss in GDP will be equal to 4. This is how much inflation I want to reduce, times the sacrifice ratio, which is 5. So that implies that we must sacrifice 20% of 1 year's GDP in order to achieve that. Of course, this is something theoretical, and I mean, this might be different from one country to another, so it doesn't have to be 5%. So just for example, if it is 5%, so that means we need to lose 20% of GDP, but also this loss doesn't have to happen in a single year. This could be, spread out over several years, and so on. So, and that be the cost of this inflation is the loss in GDP. So anyway, so this is some concept we discussed in the videos, and also I talked briefly about rational expectations. So we already discussed adaptive expectation before, and we said when people or when economic agents form their expectations about inflation, sometimes they just basically use the most recently observed inflation rate, so pi t minus 1, okay? But other mechanisms suggest that rational expectations suggest that people base their expectation on all available information, including information about current and prospective future policies. So basically, it's not just pi t minus 1 or any changes in policy or any expectation about policy changes in the future. So they kind of, factor this in their expectation about inflation. So this is just a different mechanism of, expectation or expected inflation. But as I said, it's just the idea that we know from this equation here that inflation depend on expected inflation, which could be this is the equation I want to look at this here. So so expected inflation, which the mechanism through which agent form their expectation about this. So the any changes effect on this thing, pi e, but then also inflation depends on cyclical unemployment and supply shocks. So anyway, so these are things we covered in the lecture. Now I want to I'll stop for a moment, and if you have any questions, and I know there was another question I didn't answer. Okay. Could you tell us, okay, how to access manual textbook? I don't know, it's probably available in the library. So if the same way you access the Planchard book, so you should be able to access ManQ as well. So I'm sure this is like a very popular book. So I'm sure it's in the library. So if you can't access and if you really want to study this chapter or any other chapter from ManQ textbook, just let me know, and I'll check with the library, or you can check directly with the library if you can't see it. But I'm sure it should be there. Anyway, so let me now move to the tutorial questions, which I wanted to go through quickly today. I might not cover all questions in the tutorial sheet, but the answers will be, I'll post answers on Learning Central, maybe on Thursday after the last tutorial session. So, okay, so this is the tutorial sheet. This is the file that, you said it's been deleted from Learning Central. I apologize for that. I might have done that by mistake, but I thought I have already uploaded on Learning Central. So I'll check the link. So if there's a problem with the link to this file, I will update the link, and that should give you access to the questions. So in this question, as I said, the first question you need to answer here is, how is the Phillips curve related to aggregate supply? And this is a question that we already covered in the recap. So I'll go through this the answer very quickly and in a moment, but let me just look at the other questions as well. So in question 2, explain the differences between demand pull inflation and cost push inflation. Again, these are two causes of inflation, and again, we just covered this in the video. So it's just a textbook, textbook questions. The third question, it sounds like, it looks like you will have to do some calculations, or a lot of calculation, but it actually doesn't. It's just very, it is not the case. It's just very straightforward calculation. So here, we were given the equation for the Phillips curve, and we were asked to find out the natural rate of unemployment and to graph the short run and long run relationship between inflation and unemployment. The third point, it asks about how much cyclical unemployment is necessary to reduce inflation by 4%. And the last question is, again, just very similar. If inflation was at 6% and the central bank wants to reduce it at 2%, how could we do that? Okay, so in terms of the first question, as I said, we already answered that question. We know how to drive the Phillips curve from the short-run aggregate supply curve. So what you see here is this equation here is the short-run aggregate supply curve. It's again output. It tells us that output depends on the full-time, for employment output level, and the unexpected level, price changes. So the deviation from prices from its expected level. So the idea here is that this is the difference between the price level and the expected price level. Okay, so Phillips curve tells us similar information, if not the same, but just in a different way. Okay, so, and that's why many economists will treat Phillips curve as the same thing as the supply curve. Okay, so both are the same thing. So the Phillips curve, as I said, is an alternative way to express aggregate supply. So basically, it tells us, okay, there's a trade-off between inflation and employment. As you can see here, which is something already given in the short-run aggregate supply. So the trade-off here appears from the fact that we have inflation in the left-hand side, and we have this is a negative coefficient here, which is basically there's a negative relationship between cyclical unemployment here, this one, and the inflation rate. So this is something, again, it's already this information given by the short-run aggregate supply curve. So in this case, on this equation, inflation depends on expectation about inflation and cyclical unemployment and supply shocks. So as I said, so both equations they tell us the same information but in different way. So, and both equations tell us that real economic activity depend on or related to unexpected price changes or unexpected changes in inflation. So you see, notice that in the short run aggregate supply, we have prices, but in Phillips curve, we talk about inflation, okay? So both are kind of the same thing, and both tell us that there's a negative relationship between inflation and the unemployment rate. So that is that's the first question, as I said, which asks you to explain the relationship between Phillips curve and the unemployment rate, sorry, the Phillips curve and the short-run aggregate supply or aggregate supply. So both are the same thing. They give us the same information, and these are the two equations. Which we already discussed in the videos and now in the recap today. So it tells us to or ask us to explain the difference between demand pull inflation and the cost push inflation. So obviously, just thinking about the name demand pull inflation, so it happened because of higher aggregate demand. So an increase in aggregate demand basically pulls prices and output up. So the idea here is that, okay, so this is from the demand side. When we move to the cost side, so that's something to do with supply shocks. So something like, the oil price shock that happened in 1970s, and that pushed up the cost of production, and of course that will increase prices. So this can be actually extracted from Phillips curve. So we can actually say the same thing using the equation. So in this equation here, just think of this one here as demand pull inflation. So this term, because basically the deviation, how much unemployment rate deviate from its natural rate, basically that depends on the aggregate demand at that point. So if aggregate demand is if the economy is overheated and we have too much demand, or the economy is going too fast, so basically that means the unemployment rate will be higher, will be higher, or sorry, lower than the natural rate. So it will be lower than natural rate. That means there's less unemployment, and that means there's so much demand, and that means again there's that will affect prices through the demand. So that's called demand pull inflation. On the other side, if we talk about cost push inflation, so you think about this term here, the supply shock. So supply shocks basically is something to do with cost. So anything that affect the cost of production and as a result will increase prices, that's to do with supply shocks, and that is in the equation here. That's basically this term. So just to sum up, this question is a textbook question. It's very straightforward, and we answered in the videos and the recap today. Demand pull inflation is this component here, or this term here. Cost push inflation is this term here, and that's the difference between demand pull inflation and cost push inflation. Okay, so now let's move to the third question. In the third question, we are basically given this equation. So let me just move to the question. So we're giving this equation, and we were asked to find out the natural rate of unemployment. So the natural rate of unemployment, at the natural rate of unemployment, this pi will be equal this one, or the expectation about inflation. So if these two equal, then that means basically this will cancel this, and we'll have one equation with one unknown, which is the unemployment rate. So if we solve for this unemployment rate, this will give us the employment rate at that level when these two are the same, when pi is exactly that pi t minus 1, or expectation about inflation. That will give us the unemployment rate, or the natural rate of unemployment, which at this point, if you solve for you, will be 5%. So that's why I said it sounds like you're going to calculate something, but it's actually very straightforward calculation. It's all based on our understanding of what the natural rate of unemployment is. So the natural rate of unemployment is the rate at which inflation rate does not deviate from its expected rate. So basically, or in other words, this is basically when this equal this. So when pi equal pi t minus 1. And that case, that if you solve for u, then you will equal 0.05, or meaning that the natural rate of unemployment is 5%. So that's the first point. in this question, which again, as you see, it's very straightforward, so it's not really difficult to find out. So the main point here is that at the natural rate of unemployment, these two will be the same. Okay. So looking at, is that clear, guys? So it's not like, you know, something difficult to find out, but just the main point here is that you understand, is to understand that the natural rate of unemployment, at the natural rate of unemployment, pi will equal pi t minus 1, or the actual inflation equal the expected level of inflation. So the second question, or the second point, asks us to graph or to plot the short run and long run relationships between inflation and employment, and that's basically the short run Phillips curve and the long run Phillips curve. So this is something very easy to do, but when you do that, if you have a question like this in an exam or in a test or anything, so you basically need to use the information you're given in the question to answer the question. The reason I am saying this, because in the class test, I've seen many cases where students just plot, for example, the LS and the IS and LM curves without using the information they were giving in the question. So in the question, you were giving to like equations for or some information to calculate or to solve the equilibrium output and equilibrium interest rate. And then the next point, you were asked to plot the curves. So some of you, when they plot the curve, they actually didn't label the curve properly, and they didn't put you know, the equilibrium point, which they already found out. So they correctly find out the equilibrium point in point A, for example, and when we move to point B, they actually didn't use that on the curve. So my point here, what is related to what we are doing now, is basically, it's not just about you know, plotting a downward sloping curve for the short run Phillips curve. You need to make sure that you put inflation on the vertical axis, and employment rate on the horizontal axis, and downward sloping curve. And why it is downward sloping curve, we already know that from our understanding of Phillips curve, but also the equation we have here, this parameter here is minus 0.5, which means that these two are negatively, you know, correlated. And the slope is actually 0.5. So I know the slope. So I was given the slope. So I know that the slope of this curve here. Sorry. So I know that the slope of this curve is actually it's negative, meaning that it's downward sloping like this. And also that I know how much, or the magnitude is, how much the slope is actually 0.5, and that's from the equation. So, and also we said when inflation, or when pi equal pi t minus 1, or when actual inflation equal expected level of inflation, that's basically our natural rate of unemployment, which we already know how much that is. It's 0.05. We already solved that here when we found out this in point A. Okay, so, and at that point, we know that the long run Phillips curve will be a vertical line. Okay, and as you can see here, the point here where that, or the position of that long run Phillips curve. Remember, we said in the short run, prices are fixed. In the medium run, prices might be a bit sticky, but there's still, like, there's chance to negotiate and moving prices. But as we move to the long run, prices becomes more flexible. So it's fixed in the short run, more flexible in the medium run, sorry, and in the long run they are perfectly or completely flexible. So that's why you see vertical line here, long run Phillips curve. And my question is, or which curve that is very similar to this curve, that something we covered before? Which curve we did before that is very similar to the long run Phillips curve? Yes, that's true. That's the long run aggregate supply. We just said that, guys, a few minutes ago, that many economists will treat Phillips curve as the aggregate supply curve. So in the long run, basically the long run Phillips curve is basically the long run aggregate supply curve. And it tells us the same information. So okay, so remember, at the natural rate of unemployment, that is exactly where the full employment output level is. Okay, so that is the full employment output level is. So that's where the natural rate of unemployment. So there's no cyclical unemployment. Okay, so the main difference here you will see if you plot the long run aggregate supply, you will just basically put output level on the horizontal axis, and it will be the where the position of the long run aggregate supply will be exactly similar to the position of the long run Phillips curve, because this is the other side of the same coin. So when we talk about natural rate of unemployment 5%, so this is basically associated with the natural rate of output, or the full employment output level. So basically that's exactly where it should be. So that's why, as I said, using many economists would use long run or in general Phillips curve as an equivalent to the aggregate supply curve. Okay, so hopefully that's clear from here now. And moving to the next question. In the next question, we want to reduce inflation by 4%. Okay, so we have this equation here about inflation, the Phillips curve, and we want to reduce inflation by 4%. Okay, so so how much cyclical unemployment is necessary to do so? Okay, so basically we want to know how much cyclical unemployment. Basically we calculate the unemployment rate and subtract that from the natural rate of unemployment. So the distance or the deviation from the natural rate of unemployment, which we already know in point A, we calculated that at 5%. So if we calculate this after, if we calculate the unemployment rate after reducing the inflation rate by 4%, that will give us the actual unemployment rate. So we can, see how much that deviate from the natural rate of unemployment, and that will give us how much cyclical unemployment we need to, to bear if we were to reduce inflation by 4%. So in this question, it's very straightforward, because all what we need to do, we want, this one is exactly the Phillips curve you've seen in the question. The only difference, I just rearrange it to put inflation and expected inflation on the left-hand side. So basically, I want to reduce this by 4%. Okay, so all what you need to do here is basically to replace this with 4% or minus 4%, exactly the same way I've done here, and then calculate the unemployment rate. So the unemployment rate at this point, so if you solve for U here, that will give us an unemployment rate of 13%. So, sorry, so 13%. So when you have an unemployment rate at 13%, and we know that the natural rate of unemployment is 5%, something we calculated in point A. So then the difference between both, that will give us the cyclical unemployment rate. Okay, so the cyclical unemployment rate here is basically the deviation between, or the deviation of the unemployment rate from its natural rate. So the unemployment rate, when we reduce inflation by 4%, we find out that this is 13%, and we know that the natural rate is 5%. So the difference between both, between 13%, the actual unemployment, and the 5%, which is the natural rate, this is basically the cyclical unemployment, which means in this case, the cyclical unemployment, that answers the question. So the cyclical unemployment is 8%. Okay, so this is very important. Okay, so it's not so much to calculate, it's just very straightforward, as I said. So all what I did here is just I basically, sorry. Yeah, that's the equation. So all what I did, I just rearranged the Phillips curve equation, and I just, I solve it for you and over the unemployment rate, and the unemployment rate that achieved this reduction in inflation rate is 13%. And I know from before that from point A that the natural rate is 5%. And the question doesn't ask me about the unemployment rate, it asks me about the cyclical unemployment, how much cyclical unemployment that is necessary to reduce inflation by 4%. So that's why I need to calculate the cyclical unemployment. And we know that the cyclical unemployment is the difference between the actual unemployment and the natural rate of unemployment. The last question is a very straightforward question, which basically it's to do with the price ratio. So what it tells us, the inflation, if inflation is running at 6% and the central bank wants to reduce it at 2%, give two scenarios. So this is what I said about the sacrifice ratio when we discussed the sacrifice ratio. Said what is the sacrifice ratio? It's basically the percentage that you how much you need to lose from the output. At that point, you just multiply the sacrifice ratio multiplied by the inflation, how much inflation you want to reduce. So for example, here, if inflation, I want to reduce inflation from 6 to 2%, if that is that means 4%. So if I want to reduce inflation by 4%, if the sacrifice ratio is say 2%, so 4 times 2, that will give us 8%. So the question here basically is telling you how we're going to do that. The GDP loss of 8%. Okay, according to a sacrifice ratio of 2%. So where did I come with 8%? How did I come up with the 8%? Is basically how much you need to reduce from inflation multiplied by the sacrifice ratio. So if the sacrifice ratio is 2%, for example, and I want to reduce inflation by 4%, so that's from 6 to 2. So that means the loss of GDP will be 8%. So it's 4 times 2. So the two scenarios here basically is you could, one, you could deal with high unemployment rate in 1 year, and basically the 8% of GDP loss, you just bear that in 1 year, or you could spread that over time. And that's what I said when I explained that in the videos and in the slide when we did the recap now. So the idea here is that theoretically we could do that. So basically, rather than reducing the 4% over 1 year and just bear the loss of GDP in a single year, I could spread that over a couple of years. And that's basically what the question wants you to discuss, is basically the idea that whether to accept that or to take that in 1 year, to bear all that loss in 1 year, or to spread that over several years. So before I conclude the session, I just want to refer to these questions, the extra questions not have answers on Learning Central. As I said, I will post the answers at the end of this tutorial, not this tutorial, the round of tutorial, which is Thursday. So the last tutorial group is Thursday, so I post the answers on Thursdays and the video as well, the recording on Thursday. But when I post the solutions, basically there will be no answers for these sort of questions, the extra questions. So this question is a textbook question, is using wage and price setting relation, explain how the natural rate of unemployment is determined. The second question, or question 5 here, is using the 4-quadrant diagram to drive the aggregate supply curve. This again, we did this in a separate video. And then the question 6 is basically, or the remaining question is basically some basic concepts about employment and some the structural employment, the frictional employment, and cyclical employment. Just very straightforward definition. So I will stop at this point. I'll stop sharing my screen and stop the recording. I'm just recording this in case if I couldn't record or if there's any wrong happened with the recording of the last storage. So this one is recorded now, so hopefully we'll have it all without any problem. So let me stop the recording and take a few questions before we conclude the session.